Good day all. This is the continuation of the previous video where we were dealing with the sketching of the graph and answering the previous question from the EDB Eastern Cape November, May-June 2023. It was from 2023, May-June, from the province of Eastern Cape. We have dealt with all the questions from 8.1 to 8.3. Now 8.4 want us to say, hence factorize f at x completely. And then it was given that the coordinates of the turning points are approximately 0.7. 0.7 is 2 minus 12. This is the first turning point. This is the second turning point. And then this is our zeros, which at minus 5 and at minus 1 and at 2. They wanted us to draw this graph and label it. This is how you draw the graph. And then you go into the next question, 8.5. Remember, you must show the minimum. Our gradient here is minimum because we are going to use it to answer the question, because they are saying you can use your graph to answer the following questions. So you show that this is maximum, this is minimum, this is our turning point, first turning point, second turning point, our x-intercept, x-intercept, x-intercept. Now to go and answer question 8.5, 8.5.1, they say, in fact it's 8.5, then let me write the description of the question. Use your graph to determine the values of x. For which now it's followed by the question 8.5.1, for which f, the first derivative of x is less than 0 for 2 marks. Now if we can check the derivative of the 0, when we check here, when we derive this graph, we find that the first derivative is positive here, is negative here, is negative here, is positive here. So they want all the x values. So we start finding that our x from here to here is where the f dash x is minimum or negative. So x is going to be, x is equal to, it is from here, negative 2.4 up until 0.4. So from here, all this up until here, our first derivative is negative. This is what is required. 8.5.2, the question says, use your graph to determine the values of x for which the gradient for which the gradient of a tangent of tangent to f will be minimum. Now we can check the gradient of the tangent, which will be minimum. This is where we have found that the gradient of this curve is minimum here and it is maximum there. So we take where x is equal to 0.7. That's where our minimum gradient of the tangent is. So we find the question continues to 8.5.3. Find f at x, the first derivative multiplied by the second derivative must be less or equals to 0. In other words, it must be 0 or negative. So if you can come and check at our graph here, you can take the product of f dash. Our first derivative here is positive. Our second derivative here is negative. Our first derivative here is negative. Our second derivative here is negative. Here, our first derivative is negative. Our second derivative is positive. At this point, our first derivative here is positive and our second derivative is positive. Hence, they want us to calculate or to find the value of x at which the product of f dash, the first derivative and the second derivative, must be minimum or equals to 0. If we take this, a negative times positive gives us a negative. A negative times positive, a negative times negative gives us a positive. We overrule this one, it's out. A negative times positive is negative. That is what they want. A positive times positive is positive. So they want us to get a negative. So we are going to say for the intervals, the value of x is an element of, must get a negative here, from all the way from the negative x-axis up until here at -3 is to 4. So we say from all the way of negative infinity up until -3,4. That's where we found our product to be negative. Again, we find it here. Here our product is also going to be negative. Where do we start about this one? We take it from, if we can say, from -1. This union must be here up until here. From -1 to 0,7. This is what is required of you. If you are given something like this where you have to multiply them, you just do yourself a little bit of sketch so that you'll see where does all this thing comes into place. Now we are done with this question. We have to continue to do other problems that will follow. Uncle Pythagoras signing out. Please do not forget to like and subscribe and share it, send it to others so that they can all see it. Thank you very much.